All right, so when we talk about solutions, we need to talk about concentration. So concentration tells us how much solute we have in a given solution. So it's the amount of solute in your solution. So we can measure concentration a lot of different ways. We use molarity, there's molality, there's parts per million, parts per billion, there's percentages by mass and by volume. There's also a normality, which is very old school, but there's a lot of different ways that we measure concentration. So concentration is going to be the amount of solute in a solvent. If something is dilute, there's a low amount of solute in that solution. If it's very concentrated, you should have a lot of solute there. So when we say dilute, you should only have a very small amount of that solute. Now, molarity is the main way that we measure concentration in here. So molarity is equal to the number of moles of solute per liter of solution. So molarity, when we present the unit, we say it's big M. That big M means moles per liter. So let's say that my molarity is 2 big M. That means that I have 2 moles per liter. So a molarity is also a conversion factor between moles of solute and liters of solution. So if my molarity is 2, I have 2 moles for every 1 liter of solution. So we use molarity as a conversion factor to go between moles and liters of a solution. All right, so let's find the molarity of a 250 milliliter solution containing 10 grams of sodium chloride. So if I want molarity, well, I need moles and I need the liters of solution. So I don't have moles and I have a volume, but it's not in liters. So let's go ahead and convert this into moles. So I have 10 grams of sodium chloride. Okay, well, I want to go to moles, so moles goes on top, grams on the bottom. 1 mole is equal to 58.5 grams, and then that's going to be the mass of a sodium and the mass of a chlorine. So I do that, that's going to give me 0.1709 moles. Okay, so now I have moles, and I have a volume, but it's not in liters, so it has to be in liters. Well, milliliters goes on the bottom, liters on the top. 1 liter is equal to 1,000 milliliters, so that gives me 0.25 liters. So now I can just divide my moles and then divide it by my volume. That will give me 0.68 moles per liter. So we just say big M, but that means that I have 0.68 moles for every 1 liter of solution. Okay, so let's do this one. How many grams of sodium chloride are required to make 0.5 liters of a 0.25 big M, so moles per liter of sodium chloride? Okay, so if we go and we make this solution, we need to know how many grams of sodium chloride to use. So we have 2 numbers. We have a volume, and then we also have the molarity. Remember, a molarity, if we have big M, that means that there's 0.25 moles for every 1 liter of solution. So my molarity is going to be a conversion factor between moles and liters of the solution. So if I want to know how many grams, so ultimately it's asking for grams, I will look at what I have. So I'm given a volume and I'm given a molarity. So my molarity is going to be used as a conversion factor, so we're not going to start with that. We're going to start with the volume. So I have liters. Well, if I look, I have a conversion factor between liters and moles of solution. So I'm going to use the molarity as a conversion factor. So I'm going to go from liters to moles because I have a conversion factor to do that. And then once I'm in moles, then I can go to grams using the molar mass. So my starting point is my volume. Okay, so I'm starting with liters. So if I draw this map out, I know all these units go on the top. So I go to moles first, liters on the bottom, and I have a conversion factor between moles and liters because that's what molarity is. So it's 0.25 moles is equal to 1 liter. So now I can go to grams. So liters gets canceled, moles is what I have left, so moles goes on the bottom. Following my map, grams goes on the top. 1 mole is equal to 58.5 grams. That's the mass of chlorine and a mass of sodium. All right, and then I just do my calculation because now I have grams. So 0.5 multiplied by 0.25 multiplied by 58.5 gives me 7.31 grams. Now, you do have a formula for molarity. So molarity is equal to moles over liters. Yes, if you wanted to, you could use this to help you calculate the amount of grams. However, when you guys solve for volume, typically you do the math wrong. So I don't like using this. I like to use dimensional analysis because that way I know I'm not going to mess up my math. Okay, so let's do another problem. So if you were able to extract 5 grams of sodium chloride out of 2 big M, so moles per liter of solution, what volume in milliliters of solution did you have? Okay, so I'm looking for volume. I'm looking for milliliters. That's what I want. I have 2 numbers. I was given grams, and I was also given molarity. But remember, molarity is a conversion factor. So there's 2 moles for every 1 liter. We don't start with conversion factors, so I was given grams. So grams will be my starting point, and I want to get to my volume. So anytime I want to go between my mass and to a volume, I'm going to use my molarity. So I have a conversion factor between moles and liters. So I need to go to moles first. Once I'm in moles, then I can go to liters, and then I can convert into milliliters. So I have 5 grams. Well, follow the map. Moles on top first, grams on the bottom. 1 mole, and we're still using sodium chloride, so it's 58.5. That's just because it's sodium chloride. Follow the map. Okay, so now we go to liters. So liters on top, moles on the bottom. And we have a conversion factor between moles and liters. So there are 2 moles for every 1 liter. That gets canceled. So now I'm going to go to milliliters. So milliliters on top, liters needs to be on the bottom. Well, 1,000 milliliters is equal to 1 liter. So now do your math, multiply all the top numbers, multiply all the bottom numbers, and then divide. You're going to get about 43 milliliters. Okay, the other way to solve this problem would be to use the molarity equation. You're still going to have to do some conversions though. So molarity is equal to moles over liters. So yes, you have 2 moles, okay? So if I wanted to, I could figure out, okay, how many grams is that? So there's molarity is 2. Okay, my number of moles, well, 5 divided by 58.5. That gives me 0.085 moles. And then my volume is unknown. Now, the problem that usually I see is that you don't do the math appropriately here. Okay, this is on the bottom, so I would multiply it on both sides. And then what you have to do to get x by itself is you have to divide by 2. But a lot of people do not do this correctly, so this is why I always use dimensional analysis. Okay, so now let's look at one more type of problem. Now, percentage is another way that we express concentration. We will typically use molarity, but you could be asked about a percentage possibly. So how many grams of sodium chloride are needed to prepare 250 grams of a 10% by mass sodium chloride solution? Well, if I need to know how many grams of the solute I have, well, this is how much solution I have. It's 10%. So what is 10% of 250? It's 25, right? 250 multiplied by 10% would give me 25 grams. So I would need 25 grams of sodium chloride if I were going to make this particular solution.